Welcome to Crash Course AP Physics 1 by Mudita Bansal. With the exam around the corner, now it is the perfect time to revise the key concept, practice some of the questions which have been asked in the previous year and some of the questions which just clear your concept, whether it's MCQ or whether it's a free response question. We are going to practice that all in this series. So stay tuned. Let us get started with our first unit, which is kinematics. The first subtopic that from the unit is displacement, velocity, and acceleration. Distance and displacement. So what is distance and what is displacement? Distance is actual distance you travel. It is the actual path which our object travel in a given time. That is the distance. And what is displacement? Displacement is the shortest distance between initial and final position of the body in the known direction. That is we called as displacement. Distance is a scalar quantity and displacement is a vector quantity. It also contains the direction. If the object is moved, then the displacement must be there. So it is always positive value. But whereas displacement can be negative value, it can be zero if the object returned to the same point initial to final is zero, and the displacement can be positive. Okay. So in this picture, as you can see, there is a cyclist who just covered this path, this red path, which he actually covered. That is your distance, and initial to final distance, the shortest distance, final minus initial, that we called it as displacement. Yeah. Next, we will learn about speed and velocity. Speed is the distance upon time. Okay, speed is a scalar quantity. The rate of change of distance over time is known as speed. Okay, it has only magnitude and no direction, whereas the velocity is a vector quantity and it contains direction also. Velocity is a vector quantity and it has both magnitude as well as direction. And it is the rate of change of displacement over time. So what is average velocity? Total displacement happened in the given time, that is your average velocity. Next is acceleration. So what is acceleration? Acceleration is defined as rate of change of velocity is known as acceleration. So acceleration is equal to change in velocity upon time, or we can represent it with acceleration is equal to delta v upon delta t. Okay. So the unit for the average acceleration is meter per second square. Now let's solve some of the numerical. This is a question which has been asked in your previous AP exam. A lion is running at constant speed towards a gazelle that is standing still, as shown in the figure. So this is a figure. Initially, gazelle is at stationary. It is stationary, and it is moving. The lion is moving with a constant speed towards the gazelle. After some seconds, gazelle observed the lion coming towards him. So what he does, he start running in this direction, and after and hopping to pass the lion and force him to reverse the direction. So the lion basically reverses his direction of velocity and chased the gazelle. As the gazelle accelerated towards and past the lion, changes the direction and accelerated in pursuit of the gazelle. The lion and the gazelle eventually reach a constant speed but different speed. But so first of all, let us assume that one side we consider positive direction and the other side we consider negative direction. So this is positive x. I am considering it as positive direction and this is negative. Okay. So for the graph of gazelle, if you observe, so is initially it was stationary. Velocity upon time graph we have to draw for the gazelle. Station for some time the gazelle was stationary, and when he saw the lion he started increased his velocity, and after some time for some time it is accelerated. So acceleration graph is like increasing velocity, right? After some time it reaches to the constant speed. So this is the graph for gazelle. Let's talk about the lion. Lion initially was uh, going with constant speed, but in the negative direction he was pursuing. As you can see, the negative direction. So initially it was in the negative velocity. The lion. For the lion, we have to draw. This is velocity. This is time. So initially it was negative constant speed. That's why it's a parallel to x-axis. Lion also accelerated, right? This lion also accelerated, and after some time, when the gazelle approached, when the gazelle hopped over the lion, lion has to change the direction. And when there is a change in direction, so the velocity from negative direction, now it comes to the positive direction, isn't it? Right? And after some time, it will reach to the constant speed for lion and for the gazelle, right? So the graph would look like this. So which is the correct option? Which is matching with the, so A is the correct option. Okay. Now let's move to the next question. A ball traveling with speed v naught rolls off a desk and lands a horizontal distance x naught away from the desk. Then the ball rolled off with the speed 3 v naught. What horizontal distance will the ball land from the table? Now, in this question, this velocity v naught, this is the x direction and this is the y direction. This is negative y, okay, and this is negative x. These are the coordinates I am assuming. So this is positive x. So x velocity v naught is equal to the distance traveled in x direction upon time, and this time is dependent on this height. Time is dependent on this height. Since in the two cases where the ball is thrown with the velocity v naught and the ball thrown with the velocity thrice of v naught, the time would be same because the vertical distance has not been changed. So I can write that 3 times of v naught is equal to x. X we don't know, we have to find x dash upon time. Time is same. This time and this time is same because the vertical height is not changed. Time depends only on the vertical height, that we will see in the projectile motion. So what we do, we just find out the t value from this equation, from this first equation, which is t is equal to x naught upon v naught, and substitute in the second equation, which is 3 v naught is equal to x dash upon time. Time is x naught upon v naught. So what is x dash? 3 of v naught into x naught upon v naught. So what we get? X dash as 3x, 3 times of x naught. So B is the correct option. This is a free response question. A horizontal velocity of the student moving in a hallway as shown in this graph at t is equal to 0. So the position vector at time 0 is equal to the 3.5 meter. Already the student is standing. If I make a line like this, okay, and say it is x is equal to 0. Let's say the starting of the hall is x is equal to 0. Then at time is equal to 0, the student is standing 3.5 meter away from the door, okay, away from the x naught. Determine the position of the student at x is equal to 3 seconds. So from this graph, we have to determine where the student, what is the position of the student. So if you see in from 0 to 2 seconds, 2 seconds, okay. This is the distance traveled, okay, and this rectangular part, let us say it is a1, it is a2, okay, this is positive, whereas after 2.5 second, 2.5 second, the velocity is negative. Velocity is negative means the student must have turned and came back on the same path. So that's why it is negative. A3 is negative. So let's find out what is area 1. I am writing directly in this. So area 1 is 2 into 4. It is 8 meter. And what is area 2? This triangle area, half base into height. So base is 0.5 and height is 4. So it would be 1 meter. And this A3 area is half base into height. Base is again 0.5 and height is like 4, because 0, 4, if I take magnitude, it is 4, it would be 1 meter. So what must be happening, like at time is equal to 0, the student is at this position 3.5 meter. After 2 seconds, after 2 seconds, at t is equal to 2, t is equal to 1, at t is equal to 2 seconds, the student has covered 8 meter distance, 8 meter distance. Okay, so it is x is equal to 11.5 meter. It is at new position, just add 8 in 3.5. After at time is equal to 2.5, this distance is also covered. This distance is what? This is x2, and this point is x2.5, and at 2.5 the student was at position, just add 1 in it, it would be 12.5. At 2.5 second, student reverses its direction. At 2.5 second, the student turns around and started going back to the towards this direction. Okay, so at time is equal to 3, the student covered 1 meter again. So this is time 3. T is equal to 3 seconds. The student is at 11.5 meter. Just subtract 1 from it. Okay, because it is in the opposite. We have to tell the position, not the distance traveled, but position at 3 seconds. So what is the position? It is 11.5 meter. X you can write x is equal to 11.5 meter. Determine the average velocity of the students between 0 to 3 seconds. So what is average velocity? We know average velocity is equal to displacement upon time. So from 0 to 3 seconds, what is the displacement between 0 to 3 seconds? If I see at 3 seconds, this is the final position and this is the initial position. So what is the displacement? Final minus initial. Final minus initial is 11.5 minus 3.5 divided by time. In how much time this displacement has been done? 3 seconds. So we get answer around 8 upon 3 meter per second. This is the average velocity. The average speed of the students between t0 and t3 seconds. So average speed, we know that the average speed is equal to distance traveled, total distance traveled upon time. So what is the distance traveled between 0 to 3 seconds? So distance traveled means all positive. So 8 meter plus 1 meter and plus 1 meter. 8 plus 1 plus 1. Okay. So it would be 10. And what is the time? Time is 3 seconds. 10 upon 3 meter per second. Okay. And this is the average speed. Average speed and average velocity is different in this case. If you have any doubt regarding the video or you want any mentoring or tutoring from me, you can email me on forcetra.physicss@gmail.com or you can scan this to DM me directly.